Okay, okay, okay. So now I'm going to take you through this important type of exponent. So let's see. Okay, it's fine. Let us say you have something of this nature. Let's see. Which one can I think of? Um, I'm just trying to think of something of which, let's see. Okay, looks like I got what I was looking for. Okay, problem type A, let's say you have something of this nature where you have 3 to the exponent of x that you plus it by 1. Notice something. This time around, you have a plus in between. Then that becomes 2 multiplying 3 to the exponent of that x that you plus it by 2. And then we divide this thing by 7 that is multiplying 3 to the exponent of 3. What type of problems are these? These are still, you are dealing with the exponents, but involving factorization. So the moment you have a sign of a plus or a minus there, it could be there or at the bottom. You just need to remember that you might need to factorize. And since you are going to simplify, because this is an expression, then you end up having something that looks like 3 to the exponent of x multiplied by 3 to the invisible 1. You still have your plus. So you are just expanding this thing, honorable member. Then you have 3 to the exponent of 2 there. Then this one at the bottom, you can just write it exactly as it is. Okay, so why did you do all of that? The reason why you had to do that, it was so that you can take out this and that as a common factor, whereby you have 3 to the exponent of 3 into 3 to the exponent of 1, that you plus it by 2, and that 2 you're going to multiply it by 3 to the exponent of 2, and this is being divided by 7, that you multiply it by 3 to the exponent of x. So you see, you had to factorize because you wanted that to cancel with that. And you end up having 3 that is being multiplied. Definitely this to the that is 9, isn't it? That to the that is 9. Not a times there. I don't know why I said it's a times. This, it is that 3. And then this one is 9. When you multiply it by 2, it becomes 18. So that means you have plus 18 there. And then which is over 7. Definitely 3 plus 18 is 21. And I think 7 goes how many times? Is it 3 times? I think it goes 3 times into 21. And that is the end of it. So remember, you might need to redo this. You might need to redo this exact same thing that I've done many times so that at least you'll have an idea of how it works. Okay, then it's fine, it's fine, it's fine, it's fine. And let me quickly, very, very quickly, do this. Okay. Okay. Okay, then it's fine. Let us now look at another type of a problem of which this one, let's see, what will the approach be for this one? Okay. You remember we did the difference between two squares. Let's say for some reason you're given 9 to the exponent of that. Maybe we minus it by 1. Then we end up having 3 to the exponent of that. Maybe this one is being added by that. So Your approach when you are given an expression where the letter is the exponent, which means you need to apply the lots of exponents and all of that, go for this big basis and try to rewrite it as a smaller base, you minus 1 there, then you end up having that to the that where you plus that. It's all about doing things in reverse. I'm sure you would agree with me on this one. And obviously, in this case, it says that multiplied by that. So that means you end up having a 3 to the exponent of 2x, where you minus 1, and then you end up having 3 to the that, where you plus it by 1. I'm pretty much sure that you would agree fully with me on that one. But what did I say? The difference between two squares. What did I mean by that? The moment you see this squared there, and you remember that 1 again is the same as 1 to the exponent of 2. And because of this minus, it reminds you that it is the difference between two squares. So that means to rewrite this thing nicely is the same as 3 to the exponent of x. You take out the 2 to the outside so that it will make sense when we say it is the difference between two squares. It's like you are just trying to rewrite it such that indeed it seems to be the difference between two squares. I did not change anything there. I just swapped. That's all that I did. I just swapped. Took that to the outside and then that to the inside, just so that it will make sense when I say the difference between two squares. Because even if you say this times that, it takes you back to 3 to the exponent of 2x. So why did I say the difference between? Because with regards to the difference between two squares, we will therefore have this same thing of 3 to the exponent of x. Here, if you have a plus 1, then this side you will still have that exact same thing, but with the opposite sign. You remember most the difference between two squares. So why did you have to do this thing of the difference between two? It's because now the whole of this, it's exactly the same as that, and they cancel same time. And then now you just remain with 3 to the exponent of x minus 1. And that should be the end of it. It doesn't matter, honorable member, if you are given a different problem where now let's say it's 4 to the exponent of x minus 9 there, and this being divided by, let's say, 2 to the exponent of x, where we minus 3. For me, what I know is that one of the numerators, it will be exactly the same as that, and they will cancel, and you will just remain with whatever that you remain with. And it starts with you rewriting this as what? As 2 to the exponent of 2, it multiplies with that x, it becomes 2x, minus, rewrite this thing as that, so that it will be clear that you are actually working towards the difference between two squares. Can you see it's getting closer to that one in the bottom? And then now, remember, you can now rewrite it nicely so that indeed it is clear to say you have whatever inside to the squared minus you have that to the squared. Now it is a clear difference between two squares. So now that means you will have this over that same thing of 2 to the x minus that. Trust me when I say this side, you can have it as a minus 3, but this side, it will definitely have to be a positive sign. That's it. Whereby already you see this is exactly the same as that, and same time they cancel, then you remain with 2 to the x where we plus 3. And that should be the end of it. That's it, honorable member. That's it. That's it. And for